Welcome to Kubernetes Basics for Developers course. Today in this final part of this series, we will discuss about config maps and secrets. My name is Rupam Hassan and I am a software engineer. Let's get started. Nearly every application that I have worked with over the years has some type of configuration that we need to get into it. And it might also have some sensitive data that we need to get into it. So we are going to talk about how in a Kubernetes we can do that with something called config maps, which are going to be key value pairs and secrets. So we are going to start off by talking about the core concepts of config maps, and then we will move into what is the process for actually creating a config map. And you will see it's actually pretty straightforward. And there are going to be several different options you can choose from there. Now from there we are going to go into how to use a config map, and I will also show you some kubectl commands that you can use. And then we are going to move on to what do you do when you have sensitive data. And Kubernetes supports a concept that's actually similar in functionality anyway to what Docker supports. And so we can store sensitive data in what's called secrets. So we will learn how to create a secret, and we are also going to learn how we can use a secret in our application as well. So where are we in the overall Kubernetes resources? Well, we are still in the storage area because config maps and secrets kind of fall into there. And obviously we are also going to be talking about how pods can then consume these config maps and secrets and actually use them to get data in our containers. So let's go ahead and jump on in and get started with some of the core concepts of config maps. Let's start off by talking about what is a config map first off. So a config map provides a way to store configuration information and then provide it to our containers. What's really nice about this is if you have a container within a pod and that gets scaled out and even scheduled on other nodes, then you are going to be able to get to those configuration information anywhere throughout the cluster. So it provides a really easy way to work with our configuration. Now to discuss config maps in more details, they provide a way to inject config data into a container. I started this module off by talking about that every application out there has some type of configuration data. And when you now say, hey, this part of the app running in this container now needs to get that data. But oh, by the way, this could be scheduled anywhere in the cluster. Well, that complicates things a little bit. I can just drop a file, for example, and put it on the host because if your cluster has multiple nodes, which it more likely will, then what's going to happen there? Well, it wouldn't be able to get to the data obviously. So this will work for that. So you can store data in multiple ways. You can actually put these in a file. You can register it through the kubectl command and do other things. So storing it in a file is certainly an option. What will happen, you will see that here is the file name becomes the key, and then the value would represent all the contents of the file, and then you can dive in from there to actually get the values out of it. You can also provide these values on the command line as just literal values if you'd like, and I'll show how you do. It's very simple with kubectl. That's really nice when you just want to add a config value really quickly. And then you can also create a manifest. This is actually our YAML file, very similar to what we have seen with the pods and deployments and services and other things in our previous modules, and define the key value pairs inside of this manifest. So what will happen is your config maps then can be accessed from a pod using one of two techniques. You can either access it by environment variables or you can access a config map volume, and that would give you access to an actual file system. That file system then would allow you to load that file as I just mentioned earlier, and then you can get to the values in that file. So it really depends on which approach you want to go. I am going to show you both approaches as we dive in a little bit deeper in a while. But that's the basic of what a config map does and how you can get started using them. There are several different techniques you can use to get key value pairs and data into config maps and get those set up within Kubernetes. So let's talk about some of the different options. So first off, you could do a normal config map manifest. You will notice it looks very similar to what we have seen with pods or deployments or other resources in Kubernetes. So we have our API version, and notice the kind is config map. Now one of the important parts of this, like other Kubernetes resources, is the name app settings. We are going to need that later to be able to get to the data for this config map. Now the actual configuration data itself would go within this data property, and you will notice I have enemies, lives, and even some complex properties like enemies.cheat. Whatever you want to put here, this would then be the config data that would be registered inside of Kubernetes. And then a little bit later I will show you how we can get to this based upon the name that you see app settings. Now in order to get this data into Kubernetes, we could use kubectl create and use the normal -f and then give it the file name just like we have done with pods, services and deployments. Now another option is you could get the data up into Kubernetes by loading it from a config file. So in this case, notice our key value pairs are just a normal file. Let's say this is called game.config as an example. And then we can use kubectl to get all these properties up into Kubernetes. Now that would look like the following. We would say kubectl create, we would say config map, and then from here we can give it the name, and then the important part of this is the from file, and then we can give it the path to, in this case, game.config. Now what that will do behind the scene is a little bit different than what we just saw earlier. It is still at the kind and the API version and the data property, but notice that the key and the value is now game.config. That's actually the key. It adds a separator. That's the pipe that you see, and the actual file contents are everything that follows that, enemies and lives and others. So this had a little bit different approach because we said from file name becomes the key, and then the value is actually the different properties that you see. So this is another way we could load from a file and get it up into Kubernetes if you like. Now the final technique we are going to use is you can also create what's called the environment file, and it's just properties like you saw earlier. In fact, it doesn't really look any different than what you saw earlier, but the command we are going to use to get this up into Kubernetes will be slightly different. Now let's say this is called gameconfig.env. That's our environment variables file. To get this registered and all these properties available to Kubernetes, we can do kubectl create config map again, and that's the same as what we just saw, but we can say from -env-file, and in this case give it the path to game-config.env. Now that actually create a different setup within Kubernetes. It will look a lot more like the manifest that we looked at start of this section. Notice we have a data property, and then we just have the key value pairs there. There is no file name as the key, and then the value is the entire file. Now there are different reasons why you might use one or the other, and that's going to be little more evident as we move along. So before we move on to how do we use all this, let's review these commands. So first off, if you want to load from a config file, you can say from dash file. That's the command line switch that would load it, and then just give it the path. If you want to load from an environment variable type of file, you would say from dash n file. Now you can also just load the key value pairs directly if you would like into a config map of whatever name you choose. So you will notice this from dash literal command line switch, and then the API URL would be the key, and the HTTPS URL value would be the value for that key, of course. And then you could see I have another one with other key and other value. So now that we have seen different ways of defining a config map, how would you actually use it? Well, that's what we are going to cover next. Let's look at the example of how we could actually load data from a config map into an environment variable. So you will see on the left a config map manifest in this case. Now this could have been created using the from env file switch that we talked about, or it could just be a manifest you created and added into Kubernetes. You look at the end, notice that the name is app settings, and then we have the data property with the different key value pairs. Now any pod that actually wants to use this, now you could define this in the pod template or the deployment template or something like that. You can go in and then say env, give it a name, in this case enemies. Now what's going to do is create an environment variable named enemies. Now where's the value going to come from? Well, you can see the syntax is actually pretty intuitive. Value from a config map key ref. So in this case, what's actually going to happen is aliens would be assigned to an environment variable named enemies, and then in your code that's running inside the container for the pod. You could then write the code to get to that environment variable called enemies. Of course, that would just return aliens as you see right here. Now this provides a nice easy way to just load individual settings and then put those in an environment variable. It's also possible to load all of these properties on the left, enemies, lives, enemies.cheat, and the last one there into environment variables with just one simple command. So let's take a look at the YAML for that. So if we want to load kind of everything in enemies, lives, enemies.cheat, and the last one level, then we could use on the right side. You will see env from config map rep app settings. Now what this will do is it's going to create 4 environment variables based on the keys, enemies, lives, and others, and then you could again in your code reference those environment variables just like you would any environment variable. So if it was Node.js or ASP.NET Core or Java or whatever technique you use to get the environment variables would apply here as well. Basically be made available to the pod and the containers within the pod. Now this provides a really nice way to just get everything loaded up in one shot for that particular pod. But as I just showed earlier, if you don't need everything, then you can load individual keys as well. Now we can also create a volume. Now this is a little bit different because each key is actually going to be converted into a file. So there's going to be an enemies file, a lives file, and enemies.cheat file, and you get the idea. And then for the enemies file, the value in the file would be aliens. For the lives, it would be 3, and you can see how that works. What's unique here is if the config map changes at all, then the files that are referenced by the volume would automatically get updated, and then your code would have to detect those file changes. But assuming you did that, you could then kind of have live updates. So now with that technique, I have seen it take anywhere from 30 even 60 seconds for a change to actually make its way where the container and the code could get to it. But it is kind of nice that you could just update the config map and magically the volume files that are created here also get updated. It keeps it in sync even if there is a slight delay. Now in this example, you will notice first off we are defining a volume and the name is app-config-vol, which we are going to use in a moment. But notice the config map we are going to use for this volume is app settings. What that's going to do is wherever the volume is defined, which you are going to see below here in a moment, we'll have 4 files in this example. Again, enemies, lives, enemies.cheat and enemies.cheat.label would be the files, and then the values would be inside of those files. From there, we want to use the volume mounts, and of course in our containers we can do that. So our containers property has a volume mounts. We give it a name and you will see that message with app config volume, and we give it the mount path. So what Kubernetes will do is a volume will be created at the /etc/config, and then we would have those 4 files in the volume. Now you would have to write the code to load those files, but that's where we as developers kind of need to know what's going on there, and that would be another technique that you could use. So you can see that if you prefer environment variables and your config data is not going to be changing much, then that's a really simple way to go. But if you want to have actual files for the config data, then you could use this technique. It's a little bit interesting, I think, because of the fact that each of the properties and values actually becomes a file. But that's how it works. And now let's take a look at all in this in action. We have seen how we could create a config map using several different techniques. We have seen how we can reference the config map from, for instance, pod YAML or a deployment. But how do we put all that together? Well, we are going to look at a demonstration here of config maps in action. So I have added a new demo service called Get Config Map to our Tiny Service API project. The source code link is in the description below. Also, I have added a readme file .configmaps in the project repository so that you can follow along and get the same result. Now you open up that sample API. The get config is really a basic one. It does 2 things. Number 1, we are going to read from a volume that we are going to create from the /etc/config. So if you open this config map file data source, you will see we are basically getting from our app settings. So if you open our app settings, here you go. So basically here we are going to read this enemies.cheat.label. Now if you think back to previous section in this module, we actually have this property and then it had its associated value. So what we are going to do is expose it as a volume, and then the get config map API is going to use that to get a file that's going to create it from the property. then we will read that. Then what we are going to do is display it. Now we are also going to work with environment variables. In the .NET 6 world, we can do that using this environment.get environment variable. Enemies is going to be the environment variable they are going to be after. Now that's the basic setup of what we are going to go. Now in order to run this, let's follow the readme instructions. We have that image already. Now next thing we are going to do is we move on down and you'll notice the create config map. I'm going to call it app settings, and then we are going to load it from an environment called settings.config. Let's open that setting.config file. Here we go, and you should recognize this from our code earlier that we looked at. So we have enemies is aliens, and lives is 3, and you get the idea here. If you want to do the cheat code, it looks like you can do no good rotten somewhere. Now what we are going to do from here is we want to load that. In order to load that up into Kubernetes, we are going to use the from dash in env dash file. And if you think back to the section where we covered this will actually create the data property, and then all the environment properties you just saw would be sub properties, key value pairs, and that's get that all available. Now that's one way to get a file up into Kubernetes, and we talk about several ways. Now the next thing we are going to do is we are going to apply a config map.deployment, and we are going to talk about that in a moment. And then we are going to do the port forward so that we can actually hit the web page on port 3000. So let's go back. I have already built the image, so now we need to create the config map. Now before we do that, let's see if we already have any config map. So in this case, kubectl get cm, which is the config map. So if we hit, then you will see there is no cm as app settings. Okay, so that was expected. Let's go ahead and copy this code and create our cm. Right, all right, it's created. So if we do the kubectl again, now you will notice I have app settings. There's 4 pieces of data. Now from here, let's open the CM with our YAML. So let's copy this and paste it here. So now it will open the description to our YAML file. So let's expand this. Now this is how it actually loaded it up into Kubernetes. So it took that file, added some metadata, and then if we looked a little bit up here, you are going to notice in addition to the API version and the kind, there's our data. And you can see it loaded that right up into the data property as you would expect it. So a very easy way to get this ready and available in Kubernetes. Next thing we need to do is we need to apply our deployment. Now before we actually do that, I will get it ready. Let's go take a look at our deployment file. This is where it gets interesting, and remember that we call this app settings. Now I am going to come at the very bottom, and notice I have a volume called app config dash volume, and notice that the config map we are going to use is app settings. Now of course that references what we just look at. Now scroll up a little bit, you are going to notice the volume mounts here. Now if you scroll up a little bit, you are going to notice a volume mounts here. Mount path is /etc/config, and that's going to reference the volume that then reference into the config maps. So in essence, what's going to happen, you will see, is that the 4 different properties are going to create 4 different files that we can get to through this path. So if we go back to our get config map API, and open the apps and open the app settings JSON file. We accessing slash etc slash config slash enemies dot cheat dot label. That's our volume path. And then now let's go back to our API. Now we are also going to read an environment variable called enemies. So how are we doing that? Well, now that the volume has been discussed, let's come on down and you will notice there's going to be two things I'm going to show you. First up, to create the enemies, we create an env property. Now you will notice the level is env is at, if we scroll up, now you'll notice the level is at the containers here. So the container is that tiny service config map, and then we have this environment variable named enemies. Now I only have one, but you can do as many as you would like. And where are we going to get the value of this from? Well, it's going to be a config map key ref. The name is app settings again, and then the key is enemies. So as we just look at that would come in, and alias would now be assigned to that environment variable. Really easy. Now if you don't want to handpick the properties and you want to load all of them up into appropriate environment variables, we could just do this. We could say env form and give it config map ref app settings. And we discussed this a little bit earlier in a previous section. Now that we have loaded all four of those and the key name of the properties would become the environment variable name. Now putting all this together, and we are going to run it. That means in get config map API, I should be able to get to this file there. I should also be able to get the enemies and all those other enemies.cheat, enemies.cheat.label, and all other values that we had in our config map. So going back, let's open this again in our terminal. Let's apply our deployment. So let's go back to the readme.file. Then we just copy this apply and we just hit it. Alright, it's created. Now let's grab the pod name. So okay, get pods, copy our pod name. So let's do the port forwarding. So port forward, then paste our port name, and we will use the port 3000 to enter. Alright, so the service is up and running. Now let's go to the browser and we will check it out. So now I have already opened my browser, and if we hit the URL, you are going to notice from the environment variable that enemies from the config map was loaded up, and we only reference that one key in this example, and we got back aliens. So now the enemies.cheat.label, that was from the volume, and you will notice the no good rotten here, and that was the actual value. So that's an example of how we can get a config map from an environment file loaded up into Kubernetes, and then using either a pod template or deployment or some other type of resource that needs it, we can then get those values available to our containers. Now the last thing is as a bonus, and we could go ahead and do an execute into the pod. So let's do it. So now let's go into the /etc/config that you saw earlier. So we'll do a C. So now we could do a cat on, say, cat lives says 3, cat on enemies is aliens, and you can see that these are now files that were created in the volume, and that's the process of setting up the volume. So now we have looked at config maps. Let's switch our focus to secrets. In addition to getting config into an application, there are also times when we need to get sensitive data into an application. So we are going to take a look at how to do that with something called secrets in Kubernetes. So a secret is an object that contains a small amount of sensitive data. This could be a password, a token, a key, even a certificate. And with secrets in Kubernetes, we can securely make that data available to pods and to the containers running in those pods. So Kubernetes provides a secret store for this sensitive type of information. Again, passwords, keys, certificates, and those type of things. Now that avoids us storing secrets and container images and files or deployment manifests, all of which could easily be compromised compared to putting this somewhere that's designed to store this type of data. Now we can mount these secrets into pods as files, and that will involve volumes or can use environment variables. Now we'll recall that's very similar to what we can do with config maps as well. So a lot of what we have already learned with config map is going to translate over directly to secrets. Now one of the nice features with secrets is that Kubernetes only makes secrets available to nodes that need that secrets. They have to have a pod that's requesting it. If you have a node with pods and none of those pods needs the secrets, then the nodes simply don't have that information, and that of course reduces the attack surface. Now when it comes to secrets, they are stored in TMPFS on a node, and so they are not written to disk anywhere, and that of course is a good thing as well. Now while you know this course is all about us as developers learning basics of Kubernetes, I still think it's important to know what are some of the best practices for working with secrets. And even if you're not the administrator of your production cluster, at least you can make sure these types of things are being followed. So first off, if your cluster were to stop and come to rest, if you will, and you can encrypt it, and there is a way we can do that through the link that you see here. So there is some information about that process and what would need to be done, and that of course would be important so that the secrets couldn't accidentally be stolen. The secrets themselves are stored in the ACD key value store on the master nodes, and so we want to make sure we limit access to that to only people that are trusted, and this would typically be admin users. This is definitely not an area that we would want to expose to everyone. We also want to use SSL TLS for etcd peer-to-peer communication. So as this information is being passed, we want to make sure that's done securely, as well as just in case anybody somehow got onto the network and was able to snoop around. You are also going to see why you can create a secret manifest file. The data in that it is not encrypted, it's just base64 encoded. So until it gets into Kubernetes, that kind of presents a problem, and I am going to show you that normally we can load this in through the command line through kubectl. But if you want to actually create a manifest much like a config map manifest, you could, but you would have to have extra practices in place to make sure that was secure. And finally, pods can access secrets, of course. That's really the purpose of secrets. So we need to secure who is allowed to create pods, because if they are allowed to create a pod and they shouldn't have been doing it, then in theory they could actually get to that secrets, and that would be another thing we would want to lock down within our application. So now that we have introduced the core concepts of secrets, let's go ahead and jump into some more information about how to get started using them. There are several ways that we can get a secret into Kubernetes, and we are going to look at several kubectl commands in this section. So first off, kubectl has a create secret command that you can run, and I am going to show you that you can create what's called a generic secret, and that would be for things like files or text that you want to get in. and then you can create a TLS type of secrets as well. So if you want to use this create secret command to just get a key and a value in, such as a database connection string or a password or something like that, then you can use kubectl create secret generic and then give it a name of the secret, my dash secret in this case. Now you can see that what we are adding in this pwd key and some password, and we are going to do that using the from dash literal command line switch, and that's very similar to what we saw with config maps. Now we could also use this to load files if we wanted. So if we had some type of SSH keys and we want to get those in, then we could use the from dash line command line switch. Give it a key again, in this case SSH dash private key or SSH dash public key, and then give it the path to the file, and then that would automatically be loaded and stored in Kubernetes. And then finally, if you are working with TLS certificates, then there's a create secret TLS versus the create secret generic that you saw above. You give it a name again, and then there are some different command line switches. So what you will do is give the path to the cert itself using the dash dash cert, and to the key using the dash dash key command line switch. That will load this up and make it available. And then from some server that needs this certificate, it can actually use that to do the security it needs. Now up to this point, we have declared just about every type of Kubernetes resource with YAML. So can you declaratively define secrets using YAML? Good question. Well, the answer is yes, but any secret data that you put into the manifest type file would only be base64 encoded. So you need to understand that if that file is just sitting around in source control, for example, and anybody can get to it, then your secrets might be exposed. So if you want to go to this route, you would have to be really careful to secure that type of a file, because any of the key value pairs in it are only base64 encoded. Now here is an example of what might look like. Now this could be something you could create, or it could be something that the kubectl create secret might create. It really depends on what you are doing. So first off, you will notice we have a kind of secret. We have a secret name, very important, just like with config maps, because we are going to need to reference that. And then we have the keys and the values. Now almost identically you will see two config maps. Obviously it's a kind of secret, so that's different, but the data for each key is base64 encoded here, and obviously very different from what we had with config maps. Now that's an important thing to remember, because again, if you are going to store this somewhere like source control, it's really easy to base64 decode and get to these values. So be really careful about that using a secret. Getting access to a secret is much like getting access to a config map. We can use environment variables, or you can use volumes that with that files. So first off, before I show you that part of the equation, how could we just list the secrets that are out there? Well, we could do kubectl get secrets and then do our normal -o for the output type of YAML. Now from here, if we add writes to do these things secret, notice that I can get to in this case a MongoDB password and a root password, and that's just base64 encoded again. Well, it would be really easy right on the command line actually to decode that. So this is where an administrator normally is going to shut this type of thing down to only administrators or trusted people within the organization that should be allowed to do this type of thing. So you can see the importance of locking down access to the certain resources within Kubernetes. Now when it comes to the accessing secrets from a pod, you want to access them as environment variables. Then we could do something very similar to what we saw with config maps. So over on the left you will notice we have in the data section a DB password and admin password that would have been stored in the Kubernetes secrets area, and let's say that would be like to create an environment variable called database password. To do that, you will notice we are going to get the value from a secret key ref, so not a config ref but a secret key ref, and the name of that is DB passwords. So you can see that points over to the name of the secret on the left. Now the key we would like to get is DB password from the actual data, and what that will do is now decode that data and assign it to the database password environment variable. Now using a standard environment variable access, we would write a little bit of code to get to that environment variable, and then we could use it. Now if you would prefer to use volumes to do this, then you can do that as well, and just like with the config maps, each key is going to be converted into a file. The property name or key name becomes the file name, and then the value of the property or key becomes the content of the file. So you will notice we have volumes here configured and we have secrets. Now using a standard environment variable access, we could write a little bit of code to get to that environment variable, and then we could use it. Now if you would prefer to use volumes to do so, then you can do that as well, and just like with config maps, each key is going to be converted into a file. The property name or key name becomes the file name, and then the value of the property or key becomes the contents of the file. So you'll notice that we have volumes here configured and we have secrets. Now the secrets though is going to be from DB passwords. Now you'll notice we can do our containers and we could do our volume mounts, get to that volume called secrets, and in this case we are going to say we'd like to go to etc/db passwords, and that's our mount path. Now the DB password that you see on the left and the admin password would now be put into that DB passwords folder or directory, and we would then be able to write codes to access that much along the lines of what we saw with config maps. So the good news here is the concept is very similar to what we have already seen with config maps. So there is not a lot of new things here. There are few new properties, but the general concepts of I can access this through an environment variable on the pod, or I can access this through a volume mount that I can get to through the pod and container. Well, that applies for both config maps and secrets. So now that's what we have seen, how to create secrets and list secrets and actually access secrets. Let's take a look at secrets in action. Let's take a look at how we can use secrets and access them in a pod. So I have a sample MongoDB deployment, and what we are going to do is grab the password to use for that from a secret. Now in order to do that, we are going to run kubectl create secret generic command, and we are going, so if you open the readme file, so here the step by steps we can follow now. So now in order to do that, we are going to run the kubectl secret generic command, and we are going to name the secret db dash passwords, and you can see here now we are going to use the from literal to set a db dash password, and then we can set a db dash root dash passwords. So now we are actually only going to use the db dash password, as you will see in a moment, but I wanted to show how we could use multiple literals. So if you would like, let's get our secret in place by running the create command. So let's copy and hit. So that's been created. So let's clear this and run a get secret. So kubectl get secrets, and there we go. You will notice that we have a db-passwords, and it has two pieces of data, two properties in that particular secret. Now the next thing we are going to do is we are going to get this deployment in place for MongoDB. So I am going to go ahead and start the deployment, and then we are going to take a look through what's going on behind the scenes. And you can see that that's created several things, including now I am going to go ahead and do our deployment. So copy, and you can paste it here. Yep, that's all. So here you can see that's created several things, including the storage class, persistent volume, volume claim, and then the actual deployment itself, which is in this case we are using something called a stateful set. Let's go take a look at the Mongo deployment. Now let's go take a look at the Mongo deployment. Now at the very top you are going to notice that we have two keys in our config map. We have a MongoDB DB name, and that's code with ASAN in this case, and then we have a very specific name that Mongo looks for initially, which is this Mongo underscore init db underscore root underscore username. Now this is one of those pieces of data that you may certainly choose to put in a secret. I wanted to show how we could use a config map and a secret in the same deployment, but you might move that. Now moving down, we have our storage class, which we have looked at earlier in the course. We have a persistent volume, and then finally we have persistent volume claim, and then we get to the interesting aspect of this, which is our stateful set. Now the first thing we are going to look at is I did create a volume, although we are not going to use it here. Now the first thing we are going to look at is I did create a volume, although we are not going to use it here. I wanted to show if you wanted to expose your secrets as a file, that only that pod could get to the pod being deployed through this deployment. And then we can create a volume if we wanted, to have that choice. Do I want to use environment variables? Do I want to use files that are accessed through a volume? So in this case, I have a Mongo volume, persistent volume claim that ties into the claim above. Then notice this name secret. And then we have a secret property. Now the secret name that we want to expose is db password. That's the one that we just created when we ran the command back here. Now what that will do is the two properties that were exposed, the literal properties, those are going to become file names, and then the value would be the file contents, very similar to what we talk about with config maps actually. Now if we scroll to the very bottom of this, you are going to see that we have a volume mounts, and this is going to first off set up a Mongo volume, and that Mongo volume was defined above, and then we have our secrets, and notice the secrets are going to be written to the etc/db -passwords. Now because the MongoDB image itself uses environment variables to get it initially set up, we are actually going to use that for this demonstration. But this is how you could easily get secrets exposed through a volume if you'd like. Now coming back up, let's walk through some environment variables that are going to be available to the containers of this pod. Now coming back up, let's walk through some environment variables that are going to be available to the containers to this pod. So the first one is MongoDB underscore DB name. And you will notice that's a config map reference pointing up to the config map that I just showed you earlier, and it's going to expose the MongoDB underscore DB name that you saw already. Now that name and value would be added as environment variable. Now we also have the Mongo underscore init DB underscore root underscore username. Notice that's also coming from a config map, and this is the one I mentioned you may actually decide to put in a secret, but in this case we are going to just use a config map. Now finally we have the password, and notice the value from is a secret key reference. Now this is identical to what we saw a little bit earlier in this module. We give it the name, which is the name of the secret, DB password, and then the key that we want to grab the value for is DB dash password. Now if we go back and look at the DB password had a password of well as is password. Please pick a better one for your real database, but we will keep it simple here. Then we notice that that's going to be added as the value to this variable environment variable. So now all these environment variables, all these names that you see, there's 3 of them are going to be exposed to the container in this pod. Alright, so let's try this out then and see if it worked. So again if we do the get pods, so which is kubectl get pods, you'll notice that we have Mongo 0 running. Now what I'm going to do is a port forward, so let's do this, and now I am going to switch to a tool that will allow us to connect to the database. So I am in a tool called Studio 3D, and we are going to connect to localhost 27017 port, and I have already set up the authentication. So if you do it, and the username in this case is admin and password is password, you can see, and now the admin database is what we're going to connect to. Now if we all went well and the environment variables were set as appropriate, then we should be able to test the connection. So if we try, so here, and there we go, you can see that we successfully connected, and now we could work with different collections in this database if we wanted. Now if we shell into this Mongo container, we can also check out the volume and see what we can find. So let's go ahead and do a quick execute or Mongo O. So let's stop. So let's go ahead and do the execute kubectl execute mongo-o and then tss, and now we are going to go to the volume that you saw. So let's go ahead and do the cd. So cd etc-db passwords. Let's do the ls. So now if you do a cat on db password, cat db password, you'll see our password, we can get it from here. So the volume also worked in this case, and we could use that if we wanted. So that's an example of how we can work with and not only config maps but also secrets. Definitely a valuable skills to know as a developer, because oftentimes we have to get this configuration information or sensitive data or other secrets or other things, our environment variables and all. Definitely a valuable skill to know as a developer, because oftentimes we have to get this configuration information or sensitive data into our application. Applications often need to get access to configuration data, as well as sensitive data. And in this module, we have seen how we can work with config maps to find those and then access those config map key value pairs inside the pods. We have also seen how secrets can be used to store sensitive data in our applications and how we can use very similar techniques as config maps to get to that sensitive data and expose it to the containers running in those pods. The two main ways we looked at for both of these were accessing key value pairs using either environment variables or volumes. We also looked at several key things that you could consider when working with secrets, such as not storing them in source control and ensuring that proper security is in place for not only listing secrets but viewing the output of secrets. So that's all for this final part of the Kubernetes Basics for Developers series. Hope to see you in future tutorials. Thanks for watching.